Hello everyone. In this video we are going to discuss IOQM 2025 PYQs from the chapter Combinatorics, and here's the first question. Before I read out every question, please pause this video at that time and try it out by yourself, and try to spend 2 to 3 minutes for 2 marks question, 3 to 4 minutes for 3 marks question, and 8 to 12 minutes for 5 marks question. And in this combinatorics for IOQM 2025, there is two 1 mark question, sorry, 1 2 mark questions, okay, 1 2 mark questions, 1 3 mark questions, and 2 5 mark questions. So totally we have 4 questions to be discussed here. Now let us start with first question. First question says a quadrilateral has 4 vertices A, B, C, D. We want to color each vertex in one of the 4 colors red, blue, green or yellow, so that every side of the quadrilateral and the diagonal AC have endpoints of different colors. In how many ways can we do this? Now let us draw the quadrilateral first. We will have a random quadrilateral. Okay. So let us have a random quadrilateral. Okay. Wait. So here is the quadrilateral ABCD. Okay. A, B, C and D. Okay. And they are saying that each vertex has to be colored in these 4 colors red, blue, green or yellow, so that every side and diagonal AC should have endpoints of different colors. So now we have to connect AC as well, diagonal AC. Okay, if we are connecting this diagonal AC, they are saying that AB should be of different color, BC should be of different color, similarly CD, DA and AC as well. They did not say that BD should also have same or different color. Only the lines which are connected, their 2 vertices should be in different color. Okay, and they are asking how many ways can we do this. So this is a simple counting problem. So let us see how we can do. Now let me create a table over here. A, B, C, D, A, B, C and D, and let us have first case. Okay, now if you see one thing that BD can repeat or cannot repeat, so that is the only 2 cases which is possible, because other than BD, if you try to repeat any other possible side or diagonal, it will not match the required question. So that's why the only 2 cases are where no one can repeat or where one can repeat, that is B and D. Okay, B and D having same color. Now if I name the color of A as I, okay, then B should not be with I, right, because AB. C should not be with I because AC, and D should also not be with I because AD. Okay, and since BCD cannot be I, so and BD should not be repeating, so we can have BCD with either J or K or L, or you can keep shuffling these things. Okay, alright, so if I take this factorial, you will come to know that it is going to be 3 factorial, which is 6. Okay, and also note one more thing, that I have taken A as I. Now A can be I or J or K or L, so that's why this will not be simply 3 factorial, but 3 factorial into 4, and that should be 24. Okay, so this is the first case where B and D are not same. Now let us have B and D as same. Okay, now let us have B and D as same. Let us take B as, let's say, J, D as also J. Let's take A as I. Okay, then C can be either K or L. Okay, because it can't be I or J, right? J is not possible because B, C, so J is not possible. C, D, J is not possible. Okay, and if you take B as K, D as K, then this can be J comma L, and if you take B as L, D will be L, and your C will be I and J, sorry, J and K. Okay, and the same thing which I told for the first case, A can be I or J or K or L. So here also we need to multiply by 4. Okay, so how many cases are possible? For A equal to I, 2, 4, 6. Okay, and into 4 for 4 colors of A, and that will be 24. Okay, now if I take A as J, then the ones where J is filled, that will be replaced by I automatically, so we need not consider separately. Okay, so that's why I multiply into 4, and we got the second case also as 24. Okay, now these are the only possible cases. You can try it out, you will not get any other case, and if you sum this up, you will come to know that it is going to be 48. So the answer for this question is 48. Okay, now let us move on to next question. This is also a 2-mark question. Sorry, this is 3-mark question. Now this question says there are 6 coupons numbered 1 to 6 and 6 envelopes also numbered 1 to 6. The first 2 coupons are placed together in any one envelope. Similarly, the third and the fourth are placed together in a different envelope, and the last 2 are placed together in yet another different envelope. And how many ways can this be done if no coupon is placed in the envelope having the same number as the coupon? So they are saying that there are 6 coupons. Let us have C1, C2, okay, or let us have C1, C2, C3, C4, C5 and C6. Okay, and let us have envelopes as E1, E2, E3, E4, E5, E6, and the question is saying that they are placing first 2 coupons in one envelope. So if I box the first 2 envelopes, first 2 coupons, it is going to be like this. Okay, next 2 coupons and the last 2 coupons in one another box. Okay, C3, C4 in one and C5, 6 in another one. Now they are saying that this first box should be placed in one envelope, second box should be placed in another envelope, and the third one should be placed in another envelope. Okay, and they are saying that no coupon should be placed in the envelope having the same number. That means this box cannot be placed. Now if I take this box as 1, if I name this box as 1, this as 2, and this let me name this A, B, C, A, B and C. What they are saying that A should not be in 1, 2, B should not be in 3, 4. What are these 1, 2 and 3, 4? Envelope number, and C should not be in 5, 6. Okay, so this is the condition that they have said, and with this condition they are asking how many ways is it possible to place in the envelope. Okay, now let us see how we can do this. Now for this I am going to use tree diagram. That is the most convenient way for this question. Now let me start with for coupon 1, 2 or A. You can either start with B or C, but anyway it's going to be equivalent, so I'm going to start with A. Okay, I'm going to start with A. Now if you see the one where 1 and 2 are sitting, coupon 1 and coupon 2 are sitting, if you see this A can be placed only in 3, 4, 5, 6. Envelope 3, envelope 4, envelope 5 and envelope 6, and from now on for this entire question I will be saying it as 1, 2, 3, 4, 5, 6. I will not say E1, E2 and all. So now if you see A can be placed in either 3 or 4 or 5 or 6. So this is clear that it has 4 choices. Okay, so let me write it as circular for fourth circle, and this can be split into two cases, where here it is either 3 or 4 and here it is either 5 or 6, and each with two choices. Okay, and the ones that I'm going to mark with circle, they are the ones which will be considered during the final calculation of the answer. Okay, now let me start with B over here. Here you can start with C as well, but it is not going to matter that much. Okay, so I'm going to start with B over here. Okay, now if you see, B is such an condition which cannot be placed inside 3 and 4, right? So that's why B can be placed in 1, 2, 5 or 6, right? 1 or 2 or 5 or 6. Okay, now before I move forward, I have written a 3, 4. That means A is the one who is going to be placed in either 3 or 4. Okay, similarly A is the one which is going to be placed either in 5 or 6. Okay, so that is the meaning of 3, 4 and 5, 6. Okay, and if you see for the first case of A, where 3, 4 is where A is inside either 3 or 4, then if you see, B can be placed in either 1 or 2 or 5 or 6. Okay, so here also 4 choices are there. Okay, 4 choices are there. So here 2 choices, and here you'll have 4 choices. Here also splitting will happen, where B can be in 1 or 2 or 5 or 6, 1 and 2 and 5 and 6, and here also 2 choices. Okay, and here also 2 choices. Now if you see C, the last envelope, the last pair of coupon, where 5 and 6 is sitting over here. Now if you see, if I take A as 3, B as 1, then C can be either 4 or 2. That's it, only 4 and 2. That's it. Other than that, it is not possible. You cannot place 5 or 6 also over here, because C already has 5, 6 coupon numbered. So that's why here you cannot have 5 or 6. So here, if A is 3, B is 1, then C can be 4 or 2. And if A is 3 and B is 2, then C can be 4 and 1, right? 4 and 1. So you can have a slash like this, 4 and 1. And similarly, if you take 4 over here, then you'll get 3 and 2 and 3 and 1. You'll understand it. Okay, and if you see, these are just choices. Okay, this is just an OR. It is a forced one. Okay, it depends on where A and B are sitting, and with respect to A and B, C is automatically forced to sit in one of these 4 options. And if you see, in each of these 4 cases, there are 2 choices available. So that's why here also 2 choices are possible. Okay, so now if you make B to sit in 5 or 6, now let us see how it affects the one for the last pair of coupon, which is C5 and C6. Now if you make A to sit in 3 and B to sit in 5, then C cannot sit in 6. Okay, but C can sit in, let's say, 1 or 2 or 4. Correct? If I make A as 3 and B as 5, C can be either 1 or 2 or 4. And if I make A as 3 and B as 6, then also it is going to be 1, 2, 4, because C can't be in 5. And if you change from 3 to 4, this will be 3. Okay, and this will be same 1, 2. And again, if you make B to sit in 6, then it's going to be again 1, 2, 3. Okay, so now if you see, even for this case also there are 4 possible options, but in each of these 4, 3 choices are available. So this is the 3 choice that we are going to consider. Okay, so this is the 3 choice that we are going to consider. So finally, if you see, when B is in either 1 or 2, C will have 2 choices, and these 4 cases are based on B and A. Okay, similarly, if B is sitting in 5 or 6, then C will have 3 choices, and these 4 cases are based on where B and A are sitting. Now if I take B in 5 or 6, then let's see what happens. So if I make A to sit in 5 or 6, then B can be either 1 or 2 only, because 3, 4 is also not possible, and this can be 6 if I'm making A to sit in 5, or this B can sit in 5 if I'm making A to sit in 6. Okay, so here you will have 3 cases, and this will also get split into 2, because C is the critical case where 6 and 5 should not be allowed. So that's why here also I have to split. Okay, now if I make here as 1/2 and 6 or 5. Okay, now here you have 2 choices, here you have 1 choice, because if A is in 5, then B has to sit in 6. Okay, now B can't sit in 5 as well, so that's why B has only 1 choice if either it is sitting in 6 or 5. Okay, now if A is sitting in 5 and B is sitting in 1, then C can sit in either 2 or 3 or 4. Okay, and if A is sitting in 5, B is sitting in 2, then this can be 1, 3, 4. Okay, and if A is sitting in 6 and B is sitting in 1, then it is going to be same 2, 3, 4. And if A is 6, B is 2, then it's going to be same 1, 3, 4. So this is also clear that C will have 3 possible choices. Okay, and if when I look at the second case, if A is 5, B will be 6, then C can be 1, 2, 3, 4. And if A is 6, B will be 5, then also it is going to be 4, 1, 2, 3, 4. So 4 choices are possible. Okay, now if you see in this tree diagram, let me copy it down carefully so that you will not miss it out. Okay, now if I count the number of cases over here, first thing you have to use addition and multiplication rule, which is principle of counting. Now I have to multiply each branches and then add finally. So how we will do, like 2 into 2 into 2, that will be 8, plus 2 into 2 into 3, which will be 12. Okay, then plus one more plus 2 into 2 into 3, that is going to be one more 12, and last one 2 into 1 into 4, that will be 8. Okay, 2 into 2 into 1, 2 into 1 into 4, that will be 8, and if we count them totally you will get 40. So the final answer for this question is 40. Okay, so here's the third question, and this is a 5-mark question, and the question says there are M blue marbles and N red marbles on a table. Arman and Babita play a game by taking turns. In each turn, the player has to pick a marble of the color of his or her choice. Arman starts first. Okay, and the player who picks the last red marble wins. And for how many choices of M, N with M, N range from 1 to 11 can Arman force a win? Okay, so let us solve this question. Now here we are going to classify into cases, and then we are going to do the counting part. Okay, now the first case would be when first thing you have to understand is that Arman should start first and Arman should only win, right? The question is that Arman should win for the one who picks the last red marble. Okay, so one thing is clear that M plus N should be an odd number. Why? Because Arman should start first and Arman should win, right? Because if let's say Arman picks 1, then Babita picks, okay, let's say like this, Arman picks, then Babita picks, then Arman picks, then Babita. Now if you have even number of balls or even number of marbles, then you will see that Babita is the one which is appearing in the last. If you want Arman to be in the last, then one thing is clear that M plus N should be an odd number. Okay, now how M plus N can be odd number? Either M can be even, N can be odd, M even, N odd, or M odd, N even. Okay, now we know that M is blue marbles and N is for red marbles. Okay, so let me make this as blue, and let me make this as green, and this is your red marble, this is a blue marble. Okay, now first case, if I keep N as even and M as odd. Okay, this is even and M as odd. This will be the first case. Okay, now if I do this case, then what will happen? Then what will happen is that, yeah, now if you see M should be odd, so it can be either 1 or 3 or 5, 7, 9 and 11, correct? And even can be either 2 or 4 or 6 or 8 or 10, correct? Right, so if M is odd, then M can be 5 of these numbers or 6 of these numbers, right? There are 6 such numbers, and if N is even, then there can be 5 such numbers. Okay, and if you use principle of counting, multiplication principle of counting, then we will come to know that the first case there are 30 such combinations of M comma N. Okay, now if I move to the second case where M is even and N is odd. Okay, M is even and N is odd. Now here also you'll have two cases. Why? Because there's going to be very special case when you keep N is equal to 1. Okay, very special case if you keep N is equal to 1. Now why this is a special case? Because Arman should win and Arman should start first. So if Arman immediately picks a red marble, he will immediately win. So that's why this is a very special case. And for this special case, one thing is very clear, that M can be any number. Okay, M can be any number. It will not be an even also, it will be an odd also. Okay, M can be any number. Now if I write, okay, M can be any number from 1 to 11. So that's why here you will have 11 cases. Okay, this is the only special case. Okay, now if we have N is greater than equal to 3, then what will happen? N is greater than equal to 3, then what will happen is that the one with M, now this M will have 5 choices, either 2 or 4 or 6 or 8 or 10. Okay, 5 choices, and since N is greater than or equal to 3, so N will also have 5 choices, correct? So 3, 5, 7, 9 and 11. So here also you have 5 choices, so overall you have 25 choices over here. So finally we get to know that in first case we have 30 choices, and in the second case we have 25 choices, whereas in this case where N is equal to 1, special case, we have 11 choices. Okay, so the final answer for this question is that it should be 30 plus 11 plus 25, and this should be equal to 66. Okay, so the final answer for this question is 66. Okay, now let us move on to the last question for combinatorics of 2025. Okay, a regular polygon with n greater than equal to 5 vertices is said to be colorful if it is possible to color the vertices using at most 6 colors, such that each vertex is colored with exactly one color, and such that any 5 consecutive vertices have different colors. Find the largest number n for which a regular polygon with n vertices is not colorful. Okay, so they have darkened the knot as well. Now they are saying that it is said to be colorful if it is possible to color the vertices using at most 6 colors. Okay, note these words, at most, that is very important. Okay, you can't take directly 6 colors. They are saying at most 6 colors, so you can have 0 color, 1 color, but 0 is senseless. Okay, so you can have 1 color, 2, 3, 4, 5, 6. Okay, and they are saying that each vertex is colored with one color, and any 5 vertices, consecutive vertices, should have different colors. So this is the meaning of colorful. as per this question. Okay, now if I take any 5 at now, first thing remember, one thing is very logical, that if you want to make any 5 consecutive vertices different, okay, if you want to make any 5 consecutive vertices different with whatsoever value of n, then one thing is clear, that you can't use one color, two colors, three colors and four colors. This is not at all possible, else it will not even be colorful. Okay, this will not even be colorful. Okay, this will not even be colorful, so this is completely eliminated. Okay, so if you want to be colorful, then one thing is possible, that 5 or 6, only these two number of colors. If you use either 5 colors or 6 colors, then it can be colorful or it cannot be colorful. Okay, it may not be colorful, so colorful or not colorful. So that's why to find the answer of n, we should only work on 5 and 6. We need not work on 1, 2, 3, 4. They are automatically not colorful. Okay, so let us see how we can do this. Okay, now one thing is clear, that now if I start with 5 colors, okay, let me do it in next page. If I have 5 colors, case 1, 5 colors, using 5 colors. Okay, then one thing is clear, that you can represent n in terms of 5k or 5k plus 1 or 5k plus 2 or 5k plus 3 and 5k plus 1, correct? So 5k plus 4. Okay, 5k plus 3 or 5k plus 4, correct? We can represent that n with these 5 forms. Now if n is in the form of 5k, then all vertices will be colorful. If you take 5 colors, then it will be a colorful one. Whether you have 5 vertices or 10, 15, 20, they will be colorful. So if n is in the form of 5k, then it will be colorful always. Okay, if you pick 5 colors. Now if you pick n in any of these 4 forms, okay, whether 5k plus 1 or 5k plus 2, 5k plus 3 or 5k plus 4, one thing is so sure, that this is always going to be not colorful. Why? Because you can apply the same logic I have said here. This same logic applies to this 5k plus 1 to 5k plus 4 forms as well. So if you pick any of these 4 forms and equate with n or assign with n, then it is always going to be not colorful. Okay, so for these 4 forms, it is always not colorful. Okay, always not colorful. You can try it out, you will come to know that it is always not colorful. Okay, logic wise, this is the logic. Okay, this is the logic. Okay, and so this is going to be always not colorful. Okay, so n can be either in the form of 5k plus 1 or 5k plus 2 or 5k plus 3 or 5k plus 4, meaning that when you divide n by 5, remainder can be 1 or 2 or 3 or 4. Okay, having remainder 0 is always colorful. Now if I use 6 colors, okay, if I use 6 colors and if I represent n in the form of 6k plus n form, 6k plus m form, if I represent n in the form of either 6k or 6k plus 1 or 6k plus 2, 6k plus 1 to 6k plus 4. Okay, let me write directly. 6k plus 1 to 6k plus 4, and finally we'll have 6k plus 5. Okay, now again one more thing is clear, that if you write n in form of 6k, then it is always colorful. If you use 6 colors, okay, always colorful, always colorful. And if you use n in any of these 4 forms, it is always not colorful. Same logic, I have applied a star over here. Okay, is always not colorful. Okay, always not colorful. And if you use n as 6k plus 5 form, it is always colorful. Why? The same logic over here as well. So let me mark this also with a star. So 6k plus 5 is always colorful as well. Okay, so now one thing is clear, that n should be either in these 4 forms when it comes to 6 colors, or when it comes to 5 colors also it should be in these 4 forms. Okay, so now if I write this in next page. Okay, so one thing is clear, that n should be in the form of 5k plus 1 or 2 or 3 or 4. Okay, or n can be in the form of 6k plus the same thing, 1 or 2 or 3 or 4. Okay, let me write this as L, so not to equate it mistakenly. Okay, now if you want to maximize n, now the question is saying that you have to find the largest number n, so which means you have to maximize n. Now if you want to maximize n, either two options are possible. Either take 5k form and maximize the remainder, and take 6l form and minimize the remainder. That means to maximize n, for max n, either you can take n as 5k plus 1, 5k plus 1 or 6l plus 4. Either this you can take, or you can take n as 5k plus 4 or 6l plus 1. Okay, now why I am doing like this? Can I use 5k plus 1 and 6l plus 1? No, you cannot use it, because for any n greater than 0, you will not get same remainder when you divide by 5 and 6, right? You will not get same remainder when you divide 5 and 6 simultaneously. So that's why you cannot take 5k plus 1 and 6l plus 1. That is not possible. So that's why for maximum n, either n can be in the form of 5k plus 1 or 6l plus 4, or 5k plus 4, 6l plus 1. Okay, so now if you see that if n is in the form of 5k plus 1 or 6l plus 4, this is more viable than this. Now let us start listing out the numbers. Okay, now if you take multiples of 5, then you will get 5, 10, 15, 20, etc. Now let us not list as well. Okay, now if you see, if you take the difference of 6 multiples and 5 multiple, then one thing is clear, that it should be 3 over here, and if you see here, it should be minus 3, correct? If you subtract 6 multiple minus 5 multiples, you will get minus 3 over here, and if you subtract 6 multiple minus 5 multiple, you will get 3 over here, right? So we have to see where you get the 3 or minus 3. Now if I take 5 multiples, you will get 5, 10, 15, 20, 25, etc, etc. Now if I take 6 multiples, then 6, 12, 18, and one thing is clear, that when you pick 15 from 5 multiple or 18 from 6 multiple, you will see that 6l minus 5k is 3, right? And here unfortunately l became k, sir. So l is equal to k is equal to 3. Okay, this is just a coincidence. Okay, so one thing is clear, that l and k should be 3, and the form should be of this one, right? It can't be in this form as well, right? Why? Because a form should be, it should be in this form only. Okay, so finally we get to know that n is equal to 5k plus 4, and this should be equal to 15 plus 4, which is 19. If you use 6l plus 1 as well, here also will get 19. N is equal to 19. So that's why the final answer for this question is n is equal to 19. Okay, and this one where n is equal to 5k plus 1 or 6l plus 4, this is not possible. Okay, and this is the only possible case. Okay, you can try this out, you will not get any value of k or l. So the final answer for this last question is 19. N is equal to 19. So I hope you understood the solution for IOQM 2025 Combinatorics, and we will see you in the next video. Until then, all the best for your IOQM 2026.